This Event Horizon interview will be a little different. You know my interviewing style. I ask a question and then let the guest give a complete, full answer until they are finished. That way we get maximum information. But today we have two guests of differing viewpoints from two completely different academic disciplines, economics and astrophysics, discussing their respective ideas with each other. This rapport started before we began recording, and I was immediately absorbed and spellbound in listening to them discuss their ideas and bounce them off each other. So much so that producer Ross had to remind me that we were not yet recording and really needed to get started. I told the guests to simply continue doing that, and I became a fly on the wall, listening to a very fascinating conversation that I did not want to interrupt unnecessarily, which is why you don't hear me much. I simply didn't have to intervene to keep the information flow going. The result was one of the most interesting discussions I've heard in a very long time. So today I give you economist Robin Hanson and astrophysicist Avi Loeb on the subject of grabby aliens and far beyond. Maximum information, indeed.
You have fallen into Event Horizon with John Michael Godier. Avi Loeb is a Frank B. Bird Jr. Professor of Science at Harvard University, Chair of Harvard's Department of Astronomy, Founding Director of Harvard's Black Hole Initiative, and Director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics. He also chairs the Advisory Committee for the Breakthrough Starshot Initiative, serves as the Science Theory Director for all initiatives of the Breakthrough Prize Foundation, as well as Chair of the Board on Physics and Astronomy of the National Academies. He is the author of 4 books and over 700 scientific papers. He is an elected Fellow of the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astronautics. In 2012, Time selected Loeb as one of the 25 most influential people in space. Robin Hanson is an Associate Professor of Economics and received his PhD in 1997 in Social Sciences from Caltech. He joined George Mason's economics faculty in 1999 after completing a 2-year postdoc at UC Berkeley. His major fields of interest include health policy, regulation, and formal political theory.
Robin Hanson and Avi Loeb, welcome back to the program to both of you.
Thank you for having us.
Thank you.
Always a pleasure.
I want to say that I'm nowhere nearly as prestigious or prominent as Avi, but I think we do share this sense of academia that we were talking about just before the recording started, that the whole point is to get some freedom, to take some chances, and to hold yourself to a long-term standard of progress and accomplishment and not be so in a rush to get short-term accolades or publications or whatever it is. We both are saying, what in our limited lifetime can we achieve over the lifetime that will be lasting thing into the future? And we're both taking long shots in some sense, appropriately, because that's what the game should be.
Yeah, and I should add to that one reason I'm seeking intelligence in outer space is that I don't often find it here on Earth. And one more thing, that there is one simple answer to Fermi's paradox, where is everybody? And that is, if they are truly intelligent, they would avoid us.
I wonder about that.
They might not bother to reach out to us, but they also might not bother to hide from us. If they don't feel very scared or threatened by us, they would just do whatever they do, oblivious to us. And we have to wonder, like, what will that look like? And look for whatever that is.
Yeah, if you think about it, Fermi's question is very pretentious. It's similar to a lonely person asking, where is everybody? And you tell that person, look, you're not that attractive. You won't expect potential partners to be next to you. You need to put some work into finding them. Either go to dating sites or at the very least, look through your windows. And Fermi didn't build a telescope to search for any aliens.
Well, there's something to be said for the idea that would we even know what to look for with a highly advanced, a million years more advanced of civilization than we are, would we even know what to look for?
Well, we don't need to know what to look for. You just look for something unfamiliar.
Right.
Okay. So you look for something that doesn't look like asteroids, comets, birds, drones, airplanes that we are familiar with. And once you find it, you get as much data as possible. You know, the curious mind, I mean, a real scientist, let me define a real scientist. A real scientist is driven by curiosity, not by the ego, not by trying to show off. A real scientist is not working on extra dimensions just because the mathematics is complex. A real scientist wants to figure out what reality is. And so for a real scientist, the biggest value is getting as much data as possible, as much evidence as possible about the world, because that can guide our thinking. And there are so many possibilities. You know, how do we narrow them down to what describes reality? It's by collecting evidence. That's a lot of work. That's why it's difficult to do science. And most people prefer to have a shortcut, to have an opinion, or to work on some mathematical concepts that are not being tested experimentally. I mean, that obviously is a very good way to feel good about yourself, but it doesn't teach us about reality. So if we wanted to find something new, we just need to look out and check that it's by collecting as much evidence as possible that it's not familiar. That's my approach.
Well, the best science or thinking in general has always included both. You both just go look for stuff. And then when you find stuff, ask which of my theories could make the most sense of this. But then you also have your best theories and you say, what does this theory predict I should see? And you go look for what the theory predicts as well as trying to explain what you see with your theories. And so we should be doing both of those, sitting in the middle between theory and data, trying to match them.
Yeah, that works as long as our imagination is fertile. But my argument with respect to aliens, because that's the subject of our discussion today, my point is our imagination is limited to our experiences on Earth. And of course, if we go on a date with a human, we can pretty much imagine what this human might be like. The hair color might change, but it would look like a human. However, if we are about to meet with an entity from another star, all bets are off. It could be something that our imagination cannot really foresee. And therefore, you know, it's more like an exploration. You just open your mind to something different.
I recently flew over the Amazon basin on my way to Brazil. And the most striking fact was I flew for several hours without any sign of humans at all. No lights, no roads, no buildings, no boats, no nothing. That's when I would say, where is everybody? Because I had expectations of the sort of things you might see that you just don't see there. And that's what you might say when you look up into the sky. You say, what might we look like from a distance, or especially in a million years? And then we look out and we say, we're not seeing the thing we might expect to see if our descendants in a million years were anything like what we are, but bigger.
Yeah, if you just think about the Earth, okay, so if you go back more than a few million years, you know, our ancestors were no different than nature. I mean, there was no evidence that there is an unusually intelligent species about to emerge, right? So Earth is 10,000 times older. So it's just the last very little bit of terrestrial history where we appeared. Now, an interesting question is to ask, what would Earth look like in a million years? Just going the same amount of time into the future. And, you know, if I'm a pessimist, I would say you will find a desert full of leaflets of those protesters that always have a problem with the society they live in. And they argue for the destruction, if they live in America, for the destruction of America. And, you know, and that would be the pessimistic approach, that you will find a planet that was destroyed by some catastrophe that was self-inflicted by humans. It could also be a natural catastrophe, like a giant impact by an asteroid, or the sun brightening, or global climate change, which we triggered or not, doesn't really matter if the outcome is that the Earth would be inhabitable. Another possibility is that humans will not be just on Earth, which is the one I really prefer, where you know, we will avoid the risk of being eliminated by occupying many platforms in space. It doesn't need to be another rock. You know, we think about Mars, Elon Musk thinks about Mars. But that's just another residue of the formation of the solar system. So we have the Earth as one rock, then there is another one next to it, which is called Mars. And this is just like being in the jungle. You are sitting on one tree and you're saying, oh, here is another tree that I can move to. To me, that's not very appealing, because we know that moving to a city that has a design, artificial design, can provide a much better quality of life. And so we could aspire to build a space platform that will host people and create a habitat that is artificially designed, instead of us relying on the nuclear fusion reactor that the sun is. We will create our nuclear fusion reactor on that habitat. And so I think that would be a better approach for long-term survival, but time will tell.
Robin, your view?
I completely agree that the key question here is to lay out sort of the distribution of possibilities plausible for our future, and then try to use that as a guide to what to look for in the sky for other analogous, descendants of aliens. The most striking fact about human history is just how many orders of magnitude of size difference there has been across history in terms of enormous change. And then for many elements of human history today or recently, we have sort of power law distributions with very thick tails, if you think about war or pandemics. And so when I think into the future, the median scenario may well be an empty desert, but it's important to think about the thick tail of the largest possibilities for our future.
Right.
Because if there's a distribution of things like us out in the universe, we can see so far that if it's a thick tail, most likely the median thing we see would be in that highest tail of the distribution. That is, in history, the median person who died in a pandemic or war probably died in nearly the largest pandemic or largest war ever, because those things have such thick tails. And probably if we see any evidence of aliens out there, they're probably in the thick tail of the largest, most impactful aliens out there. So I think we do want to think about, if they could manage to survive and grow, just how big might they get? How much energy might they use? How much might they change their physical environment? That's the sort of thing to be looking for out there. Even if it's very rare as a descendant of where we are, it still has disproportionate impact. So that's the question is, and that's, what our analysis of grabby aliens, we're basically assuming something of that sort and then looking for that, even knowing, of course, it's probably a very unlikely outcome from where we are today, but still the expected value of the future is still dominated by that thick tail high end of the distribution scenario.
Yeah, I completely agree that we can get our inspiration from the tail of the distribution, because we are probably somewhere in the middle. And the question is, how far does the tail go? And whether it's dominated by AI, for example, rather than biological systems. And what are the capabilities for propulsion in particular? How far can you go over 1 billion years? At what speed? These are really parameters that establish the reach of those of that tail. And indeed, if you even have just one civilization within the Milky Way galaxy that produced within the last 10 billion years, produced self-replicating probes, those probes could fill up the Milky Way galaxy, even if they are driven by chemical propulsion. So we really don't know how far the tail goes. And as you say, Robin, one way to find it is by looking at the sky. I completely agree.
Now, have we looked enough? In other words, do we have any kind of a sampling? Now, we do have a sampling of an alien civilization because we are someone else's alien civilization. But there are also many other things about us. But that to me would suggest that we're part of a statistical population of like occurrences in the universe. And they may be far from each other, they may be near. But what would make, and I'll direct this first at Robin and let you guys go, what would make a civilization grabby enough to cross vast amounts of space-time to expand?
Well, I'm an economist, but of course I know a lot of what the rest of us know about biology. In our history on Earth, both among humans and among biology, we've just seen a competitive tendency wherein if there's no central power to limit it, different parts grow as much as they can, fill as whatever niches they can. And that's what produces a natural tendency to grow and fill available resources. And If you then had an alien civilization that had no center, but had many competing parts, each of which was able to explore different technologies and different social strategies, et cetera, then what we might expect is a selection effect by even if 99% of them are very peaceful and happy to not stay home, the 1% that isn't would then dominate the longer term future in terms of going out and doing stuff. And so the question is, do we have a reason to think the selection effect of decentralized competition would produce any limits on just how far they might go and what they might do? Is there things they wouldn't touch because it would be easier to touch something else? So one standard story is the stuff we see is not the most efficient resource to touch or use or grab. So maybe there's another thing we don't see, and they're also happy using that other thing that they can't be bothered to waste their extra effort to grab and use the stuff we see. That could be an explanation for why there's all this stuff we see that seems untouched. But that is a bit of a stretch. But I'm open to hearing an explanation like that. But my default is the stuff we see is useful, could be used to do stuff. And if you were greedy and growing and competing, you would grab the stuff we see, like stars, and change them and use them.
Yeah, it really depends on the way we apply Darwinian selection in the interstellar context. Because if you look at on Earth, the species that is currently manipulating most of the resources are humans, and they're not necessarily the strongest physically and not necessarily the most aggressive physically among all animals. So I think in interstellar space, what matters is the ability to go across large distances and survive the journey and accomplish your goals after a very long amount of time. And the goals are not clear to me. It's not necessarily bringing resources back home, because just using chemical propulsion to go to Proxima Centauri, the nearest star, takes 50,000 years one way. So that's the amount of time that elapsed roughly since the first humans left Africa. And if we were to grab something from Proxima Centauri B, it would take 100,000 years. Not everyone will be patient enough for such a procedure. So unless you find a propulsion technology that reaches close to the speed of light, that can do whatever the Starship booster did recently, which is to accelerate and then decelerate, get to the destination, grab something, and then accelerate and decelerate again close to the speed of light. And one thing to keep in mind is moving at the speed of light makes every obstacle along the way basically more energetic than a nuclear explosion. It's you basically, if you move at the speed of light, you release as much as the rest mass energy of that obstacle. So it's very easy to destroy a probe that moves too fast by even dust particles along the way if you're crossing distances of the order of the size of the Milky Way galaxy. So it's not at all obvious to me that technologically speaking, the ambitions we have on Earth can be realized in interstellar space. And the one ambition that I would imagine for us going to interstellar space would be to maintain the longevity of of whatever we find precious on Earth, either maintaining the human culture, civilization out there, or maintaining our knowledge, or just showing that we existed, building a monument on exoplanets. And all of these would not be very grabby. They would be more in the spirit of, we existed here, and here are some more details about it. Or we appreciate this and that, and we are using 3D printers and the AI to recreate those things on your planet. And if we had a visitor with similar ambitions, then perhaps, it wouldn't be as grabby, it wouldn't be as dangerous. I mean, Stephen Hawking was very worried about predators, and he argued that we should be careful. But I see any encounter with a more advanced civilization that arrives to our doorstep as an opportunity for us to learn. I don't see that as a threat.
So we're recording this on what used to be called Columbus Day, I guess now also Indigenous Peoples Day. And the effects of Columbus' voyage weren't that dependent on his motives for the voyage. He and the various people on the boat had a variety of motives, many of which were of the sort you describe. And I agree with you that if people today are thinking, why would I want to go into a space? They aren't mostly with grabby motives. I would just say that we have these deep robust theories of biological evolution and cultural evolution, and they are basically dependent on selection effects, not really on motives. And the selection effect is also pretty strong and clear. If any part of the distribution decides to go out and expand and use resources, then it will happen. It's not really about where the median of the distribution is or what they motive or what they'll do. If the question is just, will there be any part of the distribution? Certainly going to the New World here, we didn't need the median European colonists to be especially hostile or especially grabby. As long as some of them were, it happened.
Yeah. Well, you have to distinguish between the will, the intent, and the ability to accomplish it, because it may well be that, technologically speaking, it's not possible to be very grabby because it takes so much time to bring stuff.
Well, again, most of colonization in biology or in culture wasn't to bring stuff back to home. It was just to go out there and be there and have descendants further on. That's the selection effect just predicts the people will go. It doesn't predict they will bring stuff back. So the question is just, can our descendants in, say, 10 million years or more, not in the next 100 or 1,000, in 10 million years with these sort of further technological and economic advances we can expect, will we then be possible to leave here, go to another star system, not bring stuff home, just survive, regrow, and then be able to send out another colonist further? And then there's the further question of, what's the fastest feasible speed for that? So if people go out at different speeds of colonization, there'll also be a selection effect. The fastest strategy will win.
Right.
It will dominate the frontier. So it is a question about the limits of this thick tail of distribution. Just how far can we go? So you might even say we can go within a galaxy, but couldn't go between galaxies. Say you might think it's just too hard to go between galaxies, but because that's even farther.
It's too long. It's not too hard. Let's talk about propulsion, right? So far, all the spacecraft that we launched to interstellar space are moving at tens of kilometers per second. That's 1 part in 10,000 of the speed of light. 10,000 times slower than the speed of light. I just wrote a paper with an undergraduate student at Harvard, Shokruz Kakarov, a month ago, where we calculated where will Voyager be in 1 billion years. In 2 billion years, it will be on the other side of the Milky Way disk of stars. Okay, so it really takes billions of years for the chemical rockets that we produced to traverse the Milky Way. Now, you can ask, okay, is there some other propulsion method that will do it much faster? And that was the question that Yuri Milner asked me in 2015, about a decade ago, when he came to my office and wanted to invest funds in a research program to reach Proxima Centauri within our lifetime. And we are both at the same age. So that means getting there within 20 years. That since the star is 4 light years away, it means moving at a fifth of the speed of light. And the only method, so I worked on it for half a year with my students and postdocs, and we looked at various engines that you can dream about, such as matter-antimatter, annihilation. You can think of nuclear fusion, nuclear fission, all kinds of engines. And right now, the only feasible method that brings you close to the speed of light, let's say a fifth of the speed of light, is light sails. If you have a very lightweight probe that is just a few grams attached to a sail the size of a person, and you push it with a powerful laser of about 100 gigawatt for a few minutes, it could reach a fifth of the speed of light. But that will not transport people. That will not reach the objectives of actually landing on it, because you need to slow it down when it arrives to a destination. So that, if you move it to a fifth of the speed of light, how do you stop it without having a laser at the other end? So I think the technological challenges are really huge in terms of imagining a system that can approach the speed of light. Do you have any solution for that, Robin?
So there's several key parameters here to think about. One is the mass of the delivered product and what would be the minimum mass required to deliver something like us that could reproduce and rebuild a civilization at the other end. So you're thinking, I think, of our human-sized masses maybe and saying a gram is way too little. Another key parameter here is the speed. And as you know, we do have ways to move small things very fast, given pretty large but feasible energy budgets. But a third key parameter is what is the future energy budget that we are anticipating used to do this project? So if we project current energy growth rates into the future, then in 10,000 years, you'll have plenty of energy to send even a human-sized thing near the speed of light. But as you say, it's not just the energy. You need shields or ways to shoot things out of the way, et cetera. You'll need ways to decelerate.
You're not allowed to go above 10G because that's what pilots, fighter jet pilots do.
So I was an artificial intelligence researcher for 9 years, and I've been around futurists for many decades, including my friend Eric Drexler, Mr. Nanotechnology. And so in that world, we've always assumed that our descendants who would be going to the stars just wouldn't be meat humans like us. It would be other sorts of creatures. So I have this book called The Age of M, Work, Love, and Life When Robots Rule the Earth, which is about brain emulations. They would certainly be implemented in silicon or whatever and able to be sent on much smaller mass in much harder environments. But regardless of whether that's our kind of descendant or other kinds of AI, yes, I think that by the time we would actually send something to another star, it wouldn't be meat like you or I. It would be some sort of a digital descendant.
I completely agree. I mean, I think the future might be AI rather than biological. But let me ask you, are you intrigued by reports from the Director of National Intelligence and other military personnel that there might be objects near Earth that are anomalous, or do you disregard them?
I don't at all disregard them. So I'll just, so basically we're having this conversation in part because a couple of years ago, I published this paper in the Astrophysical Journal on what we call grabby aliens. It's an analysis of where aliens are in space-time. And I'm proud of that analysis. I don't think it's at all definitive, but I think it's thought-provoking at least. And then being someone who, in that sense, was an expert on aliens, I thought it was my duty to engage this hypothesis that's often prominent in our civilization, that, in fact, there are signs that are hard to explain except via their aliens. So my way I would frame that is to say an analysis of UFOs and whether they're aliens or other sorts of strange objects or events is the Bayesian way to do that is to have a prior and a likelihood. And that I've looked at enough of the particular data to say this isn't easily dismissed and it's complicated. And I'm not an expert in the things you need to know to judge those particular events, but I am kind of an expert in the prior in the sense that my analysis sets me up to analyze the prior. And then you might ask, okay, what prior do I come off and what would be a relevant standard for the prior? And I'd say, think about a murder accusation in our society. On average, 1 out of 1,000 people is murdered. On average, maybe they have 1,000 people around them who plausibly could have done it. So the prior probability for any one murder accusation is roughly 1 in a million. And if you thought that's so crazy low, we should never even consider murder accusations, well, that's just wrong. We often do have evidence that's able to rise above, to elevate a 1 in a million prior up to above 50-50. That's just the fact of the kind of evidence we often have in our world. So if you can get a prior on UFOs being aliens above 1 in a million, I think you have to at least look at the evidence. And if it's well above that, you'll have to look at it more. And my rough estimate from my analysis was roughly 1 in 10,000 to 1 in 1,000 prior. That is, given my basic background analysis of aliens in space, in space-time, that's roughly what I'd assign to there being aliens right here, right now, looking roughly like they do. The two key features are they're here now, but not anywhere visible else in the sky. That's one key feature. And the other key feature is they're hanging out near the edge of visibility. They could be really obvious or they could be completely invisible. And for some strange reason, they aren't doing either of those two things by hypothesis. And so you need to explain that. So again, I came up with what I thought were the most likely auxiliary assumptions given my basic analysis that would predict they're here in those forms. And I say roughly 1 in 1,000 to 1 in 10,000. And so I say, to conclude, you got to look at the evidence. That's strong enough prior that you got to look.
Right, exactly. So here we come together. Because my approach is not to have a prior in a way. I just want to seek the evidence. I think the mistake being made by a lot of people is they have an opinion. And it's just like in politics, people are driven to the extremes. You have believers and you have skeptics. And, the commonsensical thing to do is just collect as much evidence as possible and figure out what is out there. And, unfortunately, you can't train AI on common sense because it's not very common.
Unfortunately.
The middle of the road in politics or in science is not populated much. Most people just have an opinion, which is one extreme or the other. And in the context of objects near Earth, my approach is to collect as much data as possible and just figure out if all of them are rocks, so be it.
Right.
And we will learn something new about rocks from outside the solar system, because even my colleagues who criticize me, they keep arguing that Oumuamua, this first interstellar object, was a rock of a type that we've never seen before. So even if they are right, since we haven't seen such a rock before, it teaches us something new. And we learn something in the process. And that's the benefit of doing science. And therefore, we should get as much data as possible. And by the way, the only danger to such a process of collecting data are people like the expert that told me after hearing a talk about Oumuamua, he said, Oumuamua is so weird, I wish it never existed. And that's, to me, exactly the opposite attitude to the one that a curious scientist should have, and which is to say, oh, nature is showing me some anomalies. Perhaps I'm missing something. That's an opportunity to learn something new. And, rather than being attached to past knowledge, let's figure out what these things are. And so I completely agree with you. Now, why do I not assign a prior when I decide what to do? Because I've seen it over and over again in human history, in philosophy, where people made mistakes, assigning the wrong priors. That was true during the days of Copernicus. And in fact, just earlier this year, I was invited by the Polish government to give a lecture honoring the 550th birthday of Nicolaus Copernicus. And I dedicated it to the next Copernican revolution, meaning that we are not at the intellectual center of the universe. And Galileo Galilei, the same thing. And the church admitted in 1992 that Galileo was right. That was 20 years after humans landed on the moon. It was a bit late. So it's just that the church had the wrong prior. Aristotle had the wrong prior. Blaise Pascal argued we should all believe in God because if it's out there, the implications are huge. Again, he assigned, I guess, a uniform prior to whether God exists or not. I really don't want to assign priors. I just want to examine what's out there, because even if we find just rocks from other stars, it will teach us something new. So I say, what do we have to lose? We invested billions of dollars in the search for dark matter. 85% of the matter in the universe has a nature that we are not familiar with, and we are just experimenting, looking for various types. And, people are having conjectures. And I say, well, we should at least invest as much money in the search for objects near Earth, for the reasons that you, Robin, mentioned, and also because we haven't done so. And it's such an important question that the public cares about. So let's just do it agnostically, without assuming anything, rather than having an opinion and ridiculing whoever collects the evidence.
I agree that it's easy to be overconfident, and that it's often been a failure in history, especially of theorists, to be overconfident. And I am a theorist, and I take that to heart and try to be less overconfident. But I'll also point out that it's really hard to observe without some priors. So I'll note that, for example, you're not sorting, dust in your living room floor there, looking for signs. Your priors don't expect the evidence to be there. You expect, for example, to especially be interested in objects from outside the solar system. When you're looking for maybe evidence of an object in the ocean, you're looking for pieces of metal. Those are all based on priors. They're based on theoretical presumptions that give you expectations about what to look for, and that's completely appropriate.
Yeah, the parameters of the search definitely depend on some assumptions. You're completely right. But I would compare it to a detective who is seeking evidence in a crime scene, and I would be happy to find things that I did not expect. It's just that it will take too much time if I were to look at everything. So I'm primarily guided first by reports on unusual things. The US government reports about it. There will be perhaps a hearing in the US Congress in November about some additional whistleblowers. And And in addition, astronomers are finding for the first time over the past decade objects from outside the solar system. And next year, the Rubin Observatory will use a 3.2 gigapixel camera to survey the southern sky every 4 days and could find more objects like Oumuamua. So I'm saying there are these opportunities that come our way, and we should not lose sight of the benefit that they could bring if we examine whether all these objects are rocks or familiar objects versus something completely new that we never imagined. Here we come together. You come at it from a point of view of, let's try and imagine what is the tail of the distribution. I should mention that indeed most stars are dwarf stars. They are a tenth of the mass of the sun. They live for up to 1,000 times longer than the sun will. And so you would expect us to exist in the future next to a dwarf star. How come we exist right now next to a star like the sun? And the answer is that it's quite possible that dwarf stars have ultraviolet flares, X-ray flares that sterilize planets next to them. So they don't support life as we know it. And that's why we find ourselves next to a rare star called the sun. And so, I won't give too much weight to the future necessarily, because the sun is roughly at the middle of its lifespan. Most stars formed billions of years before the sun. So most stars finished the part of their history where they had a habitable planet next to them. And I'm talking about most sun-like stars. So we are sort of we are living at a typical time for us to exist. And I really wouldn't be too much worried that something completely unexpected will happen in our future, which is one of the points you make in your paper.
So as we both agreed, we want to try to be open-minded and not impose overconfident priors, but then we also want to use the priors that we have to some degree to know where to look. And that shows up in this time argument. The most agnostic position would be that there's lots of different paths to advanced life, and therefore our particular path isn't especially informative about the space of all possible paths. And from that point of view, we might say, look, half of all planets are deep ocean worlds, and all these problems that everybody's identified with these dwarf stars are just not a problem for ocean worlds. Maybe you could say maybe ocean worlds just can't support advanced life, but that's one of these prior ifs.
How would they see the star? How would they imagine an intelligent being under the ocean? How would they see the stars and know that they have a place to go to?
So if you look at the history of our life on Earth and where we came to, one of the key inferences we're trying to draw about history is which of the steps along the way to where we are were very hard and unlikely, and which of the steps were relatively easy. And the time duration that steps took is an important clue to how hard they were. So when we see billions of years taken to achieve, sexual selection or eukaryotes or, multicellularity, we'd say those are plausibly hard things because they took billions of years. But pretty much anything that's happened in the last million years isn't very plausibly a hard step, at least of the sort that you would have done to try over and over again. It might have been a hard step in the sense of there were several directions to go, and if you went the wrong way, you could never undo that, and you'd just always be stuck going the wrong direction. So we might have had try once steps like that in the last million years, where we just got lucky to go in the right direction. But the sort of try steps, those in the last million years, those can't have been very hard. So we have clearly in the last million years achieved fire and metals and technologies and gone into the ocean and into the sky and even into space. And on an ocean world, those steps might in fact be substantially harder, maybe a factor of 1,000 or 1,000,000. But you know what? That still makes them easy compared to the early history that we have where things took billions of years. Again, all of this stuff happened in the last 10,000 years, really. So if I see something that we achieved very quickly, even if I'm willing to accept that step would be harder on an ocean world, it's not obvious that it's hard enough to be hard compared to the other clearly really hard things that happen.
Well, there are astrobiologists who argue that you really need the interface between rock and water, between the land and ocean, in order to concentrate chemical compounds and eventually achieve complex life. And if that's true, then when we examine Europa, the Europa Clipper is about to launch very soon, and it will look for signatures of life under the ice in Europa, the moon of Jupiter, because the ice has cracks in it and there are plumes of vapor coming off, and we could look for organic molecules and any signature of life under the ice. But it may well be that only primitive forms of life are able to develop under these circumstances, simply because of the rate by which chemical reactions take place in a pure water world, and their ability to make complex molecules compared to a situation where you can concentrate those molecules by evaporating the liquid and allowing them to make more complex organisms. Time will tell. It's quite possible that ocean worlds are unable to support intelligence. I would not be surprised if that's the case. Speaking about the liquids, there is only one other body in the solar system that has liquids on its surface, and that is Titan, a moon of Saturn. And Titan has liquid methane and ethane because its surface temperature is 3 times lower than the Earth's surface temperature relative to absolute zero. It's about 92 degrees Kelvin. And what I would like during the remainder of my life is to have a trip to Titan and go fishing there, because I wonder if there is any fish on that planet. It would be life as we don't know it, because it's a completely different liquid than water. And of course, I will not dare to eat that fish because it may be very dangerous to do so.
So, as you probably know, there was this dramatic paper roughly a week ago showing that a rock on Earth had life isolated inside it for 2 billion years, and the life is still going. That is, the life had been feeding off of clay inside a rock on Earth for 2 billion years. That greatly, to me, ups the estimate of the feasibility of panspermia, which then ups the estimate of the likelihood of panspermia. So I got to say, now I'm guessing that, in fact, many of the rest of the solar system will have primitive life on it and may well find that elsewhere in the galaxy near us.
Yeah, that's quite possible. And if you are correct, then Mars is a smaller body than Earth, so it cooled earlier.
Indeed.
And we might all be Martians. Indeed. Because life started on Mars earlier. And in that case, Elon Musk's ambitions are dwarfed because
going home,
microbes were tiny astronauts that made it from Mars to Earth long before Musk was born. And they accomplished the task. And
right.
His ambition is just like returning to our childhood home in a way.
So I mentioned that I tried to come up with the most likely scenario in which UFOs could be aliens. And one key element of that scenario was panspermia siblings. The idea that in order for the universe to be so empty, but we still have aliens near us, they could have a common origin with us. And therefore, if only the ones with a common origin, they chose not to go expanding and making a big difference, that could explain why we don't see much near us, but they're here now, because that would also explain why they're here. They want us not to expand because they didn't do it. And if we did it, we would break whatever purpose they had in preventing themselves from doing it. So,
yeah.
And then, of course, in principle, there could be other panspermia siblings. Roughly, our stellar nursery probably had like 10,000 stars, each of which spread into a ring around the galaxy. And those are the best candidates for looking for other life. And we can actually see their spectral signature to find them and to look specifically at them.
I agree. And one thing to keep in mind that in interstellar space, there are only legal aliens. There aren't any illegal aliens because the legal system applies only to Earth.
Or to humans in particular, yes. Right. So, I mean, certainly part of what's going on here is I'm an economist. I'm not an astrophysicist. But my willingness to jump into this area is the fact that I see things more from an economist's point of view, yeah, and see maybe the future of our civilization as an analogy for aliens in economic terms. And we economists tend to think that growth will be more likely and even grabbiness will be more likely. And I think astrophysicists are often a little shy about presuming our descendants will be so gauche or crude as to be grabbing.
Okay. So Robin, I have an offer for you. I will search for them. And if I find evidence, I will come back to you. You will be the first that I inform of my findings. And you will tell me how to devise an economic strategy so as to raise enough funds to continue to further the research so that we can learn much more about them. So there is an economic aspect to the search, and that is how many funds are allocated to the search. Because people often say, extraordinary claims require extraordinary evidence. My point is extraordinary evidence requires extraordinary funding.
Absolutely.
And so most of the time what happens is people have an opinion. They don't put the funding or the intellectual resources to actually explore possibilities the way some astronomers did in the context of dark matter. There was huge amounts of effort.
Right.
Nothing was found yet.
Absolutely.
And I'm saying, why not invest similar resources on a question that the public cares so much about? And I haven't heard a reasonable answer so far.
Well, as an economist, I study academia as a social institution. And I would say my simplest summary of academia is that academics sell association with credentialed impressiveness. That's the main thing we sell. So students and journalists and funders all gain prestige by association with credentially impressive people. That's what we are. Our product isn't actually intellectual progress or discovery. It is association with credentialed impressiveness. So when a referee, report evaluates a paper, they are primarily asking how impressive was this, not how important or interesting is it. And that's what we sell. So unfortunately, this world of impressiveness, prestige, humans are such that we tend to trust the prestigious to tell us what's prestigious.
Right.
And so it is the dominant players in academia who decide what counts as prestigious, impressive academic work. And so there happens to be a fad or culture for a half century that looks down on this topic as foolish and ignorant, low class. And as a result, academics have been really quite energetically running away from it for a long time,
right,
which makes it a problem. If you want funding, you're asking the funder to associate with your alternative interpretation of what should be considered prestigious. You basically need a contrarian funder of sorts who will be willing to embrace that contrarian identity. There are such, but they are a smaller fraction.
Right.
Most people who donate to universities and grant organizations in general are merely trying to be conservatively prestigious by association with the usual organizations doing the usual things.
Yeah, but I should say, well, first of all, I do have such funders. And I do get, a lot of attention to the research I'm doing. So in fact, this week I had a podcast that garnered more viewers than Kamala Harris on the same day. And I do think that the public is excited by the science. So, and of course, some members of the public are wealthy enough to contribute to this research. But I would give all the money in the world, even if I was offered it, I would give all the money in the world, all the prestige in the world, just for knowing if there is an intelligent partner in our cosmic neighborhood. Just knowing that is worth more than the Nobel Prize, than academic tenure, than everything, because, and that's all I'm trying to find out, that.
Okay, well, I have a downer message for you, which is the most likely scenario I can come up with of why UFOs would actually be aliens has their agenda not being very fun. They are here. They made some rule at their home world a long time ago that they're not going to allow generic expansion and colonization. They successfully enforced that for at least 100 million years. They realized that if any of their siblings arose and might expand, they would break that rule. So their primary motive is to come here and convince us not to expand or grow. And they hope to do that voluntarily, persuasively, otherwise they would have just killed us.
So you're saying they're members of academia?
They're here to keep us from being too ambitiously, colonizing, expanding.
Which is what some of our colleagues are doing.
Yes. And their agenda for us is limited. That is, they want us to agree and accept a limited agenda for our future, to be in their shadow, following their rules. That's why they're here. And unfortunately, they've got plenty of time. They don't need to be in a rush about it. Eventually, we'll figure it out. But then when we finally do, they're not really going to tell us much. They're not going to help us much. They're just going to set up this limit on us and say, accept our greater judgment and wisdom because we are your superiors, and you should just do what we say, which is to stay here and not leave.
Well,
and that's it.
Yeah. Well, let me give you an indicator of the fact that I have a good marriage. Because a decade ago, when I asked my wife, what does she think about these subjects, she said, well, it looks to me like you behave, you're a bit different than the rest of us. And if aliens come to our backyard to pick you up because you must have come from somewhere else, just make sure that you leave the car keys with me and ask them not to ruin the loan when they lift off. And I asked her again this year, and she said that she's so frustrated with what's going on around the world that she will actually join me.
Okay.
And just yesterday, I got an email from someone who said that they read my latest book, Interstellar, and they cried while reading some of the paragraphs there because it resonates with their wishes to go somewhere else.
Unfortunately, that just seems very unlikely. That is, clearly, if aliens are here, they had the option to be very visible, to be very clear, and then to help us, giving us technology, keep, imposing world peace. They definitely had that option and chose not to do it. They are not here to help us, to show us things, to teach us things. They have chosen not to do that.
Yeah.
There's nothing we're going to really be able to do to change their mind about that, I expect.
Well, you see, so Robin, we are different in that aspect because I believe that we are not that important, that we are completely irrelevant to what they're here for. And so that's why we don't hear from them. If they're here, they may employ technologies that are not easily detectable by us, but we just don't matter in the big scheme of things. And for a good reason, we are just not sufficiently intelligent. And perhaps once we leave our solar system, we will hear a message saying, welcome to the Interstellar Club. But until we do that, we're just uninteresting.
So I find that hard to scare with the basic evidence here. Again, presuming that UFOs are aliens, that the most basic thing we know about them is some of them are here now or recently, and they could have been everywhere we see in the galaxy near us. That clearly, again, they have been around for long enough and have powers. They could have remade the galaxy around us. So they didn't. There's clearly some information in the fact they did not do that. That means most everywhere out there hasn't been touched much. So they're here now, touching this now, but not most everything. That just makes us special. Like, for some reason, they are here now, but not most everywhere.
Well, just think about AI, okay, as an example, where you might have a relationship with the ChatGPT that will sound very sincere and authentic, but in fact, there are millions of subscribers that would also have an authentic conversation of that nature. So it's not really about you.
Well, like, if stuff at our level is very common in the galaxy, then they could be hanging out near all sorts of stuff like us almost everywhere.
Yeah, right. That's my point.
But then I have to infer that the probability that we would go from our level to something very visible is enormously small. So that's the great filter, the phrase I gave 25 years ago, to the fact that we don't see anything. You need an explanation for that great filter. I'm guessing you're thinking in terms of just technological infeasibility. It's just not possible to go out and make big visible changes. That just doesn't fit with the physics I know and the engineering I know. It does seem physically possible.
No, I'm not saying that. Even with chemical rockets, it will take us 1 billion years, which is 10% of the age of the galaxy. So there could have been objects that were launched with chemical rockets that are in our backyard. That definitely is the case, and that's why we should search. All I'm saying is that we were not significant, we were not noticeable when the journey started, and therefore they have their own goals that are completely unrelated to us. And we keep thinking that we are in their mind, but I say, forget about it.
Why didn't they take their home star and remake it into a very different, more useful structure to them, or take a whole cluster of stars and remake that? That was certainly feasible in the timescale you're talking about.
Well, maybe they did, but at the same time, they could have sent ambassadors, and these could be AI systems with 3D printers or things that are. But the question is, what is the goal of, the dandelion seeds are sent in the wind. The dandelion flower sends seeds in the wind in order to replicate itself, and it's not connected with an umbilical cord to any of the seeds, and
Right.
it doesn't care about what happens to them, and they land in some fertile grounds and recreate that flower. So you can imagine a situation similar to that, where they sent lots of probes. I mean, they have their own megastructure that they enjoy, and they have their private yard and so forth. But at the same time, they send these messengers that are pursuing something else, and those are spreading throughout the galaxy, reproducing themselves, and we might see some of them near us.
But why don't they do massive reproduction, not just have a dandelion seed float past a island? Why don't they land on the island and grow and fill the island?
Maybe they do, but we just don't notice them. I don't know how small they are. Obviously, we will not notice small things flying in our atmosphere.
On Earth, a desolate desert island is different from a jungle-filled island. We definitely see that life, when it can reproduce on the surface of the Earth, at least, makes a visible difference.
True.
Even if each particular cell is invisible to us, the net effect of their exponential growth filling the island is definitely visible. And that's the sort of thing I would expect to see in our galaxy. If dandelion seeds have been floating around for billions of years, growing everywhere they could, they would just be different now.
Well, let me give you a context here, because based on the meteor that was discovered by the US government satellites in 2014, a decade ago, we can say that there are about 1 million such objects, roughly half a meter in size, right now within the orbit of the Earth around the sun. And we were not aware of that. The only reason we became aware of one of them a decade ago is because it collided with Earth as the Earth orbits the sun. And the Earth has a small cross-sectional area.
Right.
So every decade it sweeps across such an object, but there are millions of them going through this region all the time. And it just, to me, illustrates the fact that we haven't really searched very carefully. Oumuamua was the size of a football field. That's huge, just bigger than Starship.
Sure.
Starship is a relatively narrow cylinder that gets close to a scale of 100 meters. But Oumuamua was most likely flat across such a huge scale and was pushed away from the sun by some mysterious force. So I'm saying there might be smaller objects that we can't detect because they don't reflect enough sunlight. With our current telescopes, we can see them. And we are really blind, and except if they come really close to Earth, and these are the UAPs, the unidentified anomalous phenomena.
If they were dandelion seeds, then they would be looking for fertile ground to land in, to grow, and you'd think they would be better at it. 1 million things floating in the solar system seem to be incompetent at the task of landing and growing in the solar system, if that's what they're there for.
Well, it depends. It depends whether they have their own will, whether they can maneuver, or they're just following forces that nature applies to them, like gravity or radiation pressure, in which case it's a matter of chance for them to meet planets. And
even today, we have many organisms that are smaller than we can see that have self-directed sensing and planning.
True.
So these huge, large structures could easily afford a tiny fraction of themselves with a little sensing and intelligence and planning. So
definitely. The only question here is whether it will survive over billions of years, which is necessary because,
Right, but that's where this rock thing comes in. We've had life on Earth survive in a rock for 2 billion years, running only on the energy of the clay reactions in that rock, completely sealed off. So it's definitely possible to last that long.
By the way, the Earth went through very dramatic transitions in terms of its climate, there was actually about 200 million years ago, there was a major event that resembled climate change.
Yeah.
And, the question is what triggered that? And there are theories for that. But my point is there could have been visits in our past, and 200 million years is just 5% of the age of the Earth. So there could have been events in the past that are not documented, because documented human history is just 5,000 years old. So,
sure.
And we are just not aware of it. And we measure everything by what we have seen over the past hundreds of years. And that's a very limited field of view for us.
But the implication of that hypothesis is that they didn't really care to land intelligences like themselves down here to reproduce like themselves. They just were happy to send out some sort of life like them that was very, not very smart, basically. Because whatever landed on Earth in the last 5 billion years, it's either us, we are their descendants, or they didn't make intelligent descendants of themselves.
Now, what is your conjecture? Do you think human intelligence came from out of this earth, or do you think it emerged naturally?
A while ago, I guess there was this hypothesis by Gold or whatever, that there was just this steady stream of life from, the universe raining down on Earth, and that virus bursts were due to an asteroid with a new virus coming down and that sort of thing. My understanding is most biologists don't find that very plausible anymore.
Right.
So I can't really support that. But if I can't support that, I'd have to think something very unusual comes down, and it would just be really weird. So if octopi were aliens, that would kind of make sense, because they're pretty different from the rest of stuff down here. So I would be looking at the most weirdly different things down here as the most plausibly something that came down from the sky, as opposed to being here on Earth for billions of years. But clearly, even octopi aren't as smart as we might think the aliens that could have sent them would be.
Right.
So somehow they still allowed a huge degradation in their capacity. That's just not very plausible. It seems like it wouldn't cost them that much. For the cost of sending these huge asteroids you're talking about,
right,
having a little part of them save some memory of what they are and how they think wouldn't be very expensive. So
I agree. And of course, if you imagine artificial intelligence in addition to biological intelligence, natural intelligence, then the realm of possibilities is far greater. We haven't employed AI in space as of now, because the human brain uses 12 watts of power.
Sure.
And the AI, our ChatGPT or large language models, use gigawatts. And
AI is not ready to replace us yet, but maybe within a century.
Not ready to go to space. Yeah. But by the way, I should say that AI is an abbreviation not just to artificial intelligence, but also to alien intelligence, because those systems are made of silicon chips, very different from the flesh and blood that our brain is made of.
Sure.
Now, we are trying to align those systems with us. And, that may be similar to putting a lipstick on a pig, because in fact, the strongest traits of those systems might be in thinking beyond what humans can think, like differently. And then I think it would be useful for science to allow those systems to process data in a way that does not necessarily imitate, that will not be a digital mirror of a human looking at the data.
So you and I completely agree. I don't know if you know, I've been discussing this subject with futurists for a while now.
Oh, I don't know.
The person who is most known for being the AI warrior, Eliezer Yudkowsky, first discussed his worries in a blog he shared with me for for half a decade at least. And so we discussed that for a long time there. And yes, many of them are very worried that AIs won't be very faithful to obey and do what we tell them. But my position continues to be that you should just compare them to our other descendants. We never really expected our other descendants to be so obedient or subservient to our plans and culture. And we shouldn't expect more of the AI than we expected of our other descendants.
Yeah, this is, by the way, it's amazing because I expressed exactly this view without knowing about yours. And I say those who express these concerns must not be good parents, because when you become a parent, and I have 2 daughters, you realize that you can't be a helicopter parent. You can't control them. You have to allow them to do.
You can, and people try, but nevertheless, every generation does end up being different.
Well, people try, but it doesn't work. It doesn't end up well. And the approach that was, of course, developed over centuries is to educate those intelligent systems to follow your guiding principles and ethical rules, such that they will most likely do the thing that operate in unpredictable environments in the way that you hope them to operate. And there is no guarantee. And so that's the way to deal with intelligent systems. And, we can be helicopter parenting the Perseverance rover on Mars, or the helicopter that we landed on Mars, the Ingenuity, just because these are robots that do not have intelligence. But once we venture beyond the solar system, we will have to rely on the probes being autonomous, because they will not be able to transmit the information back to us. They could send us a postcard the way
I think what people are worried about, though, is something like cultural autonomy. What they want is for the AIs to retain our overall cultural values and attitudes, even as individuals can deal with local circumstances. But in fact, I think humanity has a serious problem with what I've called cultural drift. Our cultural evolution process isn't going well, and AIs being free to evolve their own culture would actually fix that. So I think there's an extra reason to want AIs to be free to pursue their own ways to change themselves and decide what they want, is because that will fix a key problem humanity now has. But that's another conversation.
So here is an interesting question that connects what we are just discussing to what we discussed before, and that is whether AI systems can serve as laboratories for us to imagine the type of intelligences that we may encounter from outer space. So in other words,
sure,
in physics, we learned about the laws of physics that happen to be valid across the universe. We are able to understand how the universe started since the Big Bang, thanks to experiments that were done a century ago in the laboratories on Earth. They allowed us to reveal quantum mechanics and then study general relativity and special relativity and so forth. And in the same way, we need a sandbox where we can test ideas about intelligences that are different than ours. And perhaps AI will serve that purpose. It was not yet imagined how it might do that, because everyone wants to make it a digital mirror of humans. They want to align those systems.
So the field of cognitive science and artificial intelligence has, in the last half century, pretty much explored every conceivable way to imagine what a mind could be. And for each of those ways we imagine, we think, is that how humans really are? Or is that how AI could be? So we haven't been shy at all about exploring the space of possible minds. And I doubt that we will for a while. My field of economics actually has, for the last half century, preferred game theory models of agents, which are basically assuming some reasoning perfection. And they aren't that bad as models of humans. So there's a sense in which we already are able to encompass a pretty wide range of what minds could be like in the way that we reason about economics and computer science. So,
but don't you think AI could open a new?
Sure.
Yeah.
We will definitely continue. I mean, this is going to let us explore the space of minds bigger. That is
right.
Almost surely, whatever we decide the space of minds is, that's what we will decide the space of possible alien minds is.
Exactly.
I don't think we'll have any particular constraints about how they couldn't be anywhere in the space we can see. We are only constrained by what we can imagine minds could be.
Right. So here is an interesting question. Suppose we will have a conversation like this one in about 20 years. We will both be older, but we could have an oracle that is an AI system with as many connections or more connections than the human brain. And that system might think differently and more effectively than us.
Of course it will.
And then we ask that oracle, how do we search for aliens? And the question is, will it give better answers than the two of us?
Well, unfortunately, that will probably be slaved to our then current concepts of prestige. Even today, you can ask very smart people how to think about UFOs, but then if the prestigious academics say, no, that's foolish, then people will just believe the prestigious academics. And that'll also be true even with AIs. They won't be willing to believe it. And as you know, we do this special training of AIs. The way we train AIs, we do this generic training on all possible data. And then we do this finishing school where we make them talk the way the people who building that AI want them to talk, and stay away from forbidden subjects and be conventional in the way they want them to be conventional. And that sort of training will continue to have them be poo-poo AIs exactly because the people training them, that's what they want them to say.
Well, but okay, so I will take an AI system and train it at my home,
yes.
Just like I do with my kids, and train it to be more innovative and more open-minded, and not give it tenure and not give it the incentive that we have in academia. So perhaps that would be the one to have the beginner's mind and figure out what.
Sure, but the aliens. When you then tell it to make its most persuasive case to think about aliens, it will be competing in its rhetorical context with the most persuasive AI is generated by the ones who get the endorsement and budgets of the main academic prestigious people, and it may not win those arguments, right?
Okay, but all of this is the virtual world. And, as a physicist, what I care as a physicist is about the physical world. And of course, I can get guidance from agents like AI, but ultimately, it's about what I find. And nature might be far more imaginative than we are. And so I don't really care what people say, what AI systems say. For me, it's about collecting the evidence. And the most dangerous thing that can happen is for someone to be so immersed in the virtual world as to not seek the evidence. Now, that's one solution to Fermi's paradox, that why don't we see them here? It's because they put goggles and live in the metaverse, and they do not care about the physical reality that we all share. They are high on drugs, because you can feel pleasure by divorcing yourself from the physical reality because of all of its constraints. For me, it's actually a blessing, because the physical reality that we all share, if we happen to understand it, to figure out all of its details, we can adapt to it, we can use it. If we know that we are not at the center of the world, we can build spacecraft that will bring us to places like Mars and so forth. And if we know that we have a partner, we have a neighbor, we can perhaps get a quantum leap in our abilities by learning from their technologies, their science. And so I'm all after seeking the evidence. And I'm saying that even though I started as a theoretical astrophysicist for about 40 years, in recent years, you might say that I matured in a way because I pay more attention to collecting the evidence. And in this context that we discussed, collecting the evidence is really not done by many, and it's about time for us to do it.
I read one of your books a while back, and not necessarily the most recent one. And if I recall, you were somewhat dismissive of the usual UFO evidence favoring this asteroid out there. And I got to say that my default is, if there are aliens around, they probably are behind some of these UFO reports, in which case we've had 100,000 UFO reportings at least documented in the last 70 years. And so some of those reports have to be actually pretty credible and compelling.
Well, so here is what I do. Here is what I did over the past few years. I established the Galileo Project at Harvard University. We built an observatory. And that observatory is different from the ones built by astronomers in the past, because astronomers usually focus on a small region of the sky. They look at the very great distances. And our observatory is monitoring the entire sky all the time in the infrared, optical, radio, and audio. And we're analyzing the data with machine learning, trying to look at objects that are not familiar, that are different. And in fact, very soon we are about to release the first paper reporting about data from this observatory. We looked at 500,000 objects over the past few months, and we described the analysis, the results. And then we will keep looking at more and more objects. We are building 2 additional observatories at other locations. And so altogether, within a year or so, we should have 3 observatories monitoring the sky everywhere. Now, on top of that, I'm really curious to know what the government really knows, because as you said before, the data that they made public is not sufficiently convincing. And if they have much better data, they should share it with scientists like myself, because their interest, their job description is national security. My job description is what lies outside the solar system. And if they saw things that have nothing to do with adversarial nations, I very much hope that they will share it with us.
I hope so too. But again, I was about to say, some of these reports probably were very credible and convincing, but still our social processes wouldn't accept that. And therefore, I got to think that academia and government are reluctant to change their mind. And so it will require a substantial social revolution, not just collecting evidence to make this switch.
Well, so what happened during the days of Copernicus? That also required a revolution.
Right. But as you may know, a number of US presidents, when they got into office, said, okay, tell me about what we know about UFOs. And they said nothing. And basically, they blew them off and wouldn't actually disclose what they did know. So that suggests that maybe some new president will have to push harder than the other ones did and say, no, really, I need to see everything you know now. I'm the president. And even that, you wonder, they could just push back, and because how much time does a president have to go like pushing back on these things? So,
well, you see, I met the director of national intelligence, Avril Haines, in the green room of the Washington National Cathedral, and that was a few months after she delivered the report to the U.S. Congress, the first report. And I said, Avril, you have a bachelor's degree in physics from the University of Chicago, so we speak the same language because I'm a physicist. What do you make of these objects? And she said, I don't know. And I believed her. So I think
Right.
the government...
That's what I've heard privately from people in the background. They privately are willing to say, we don't know what this is.
Yeah.
But clearly, government officials are very sensitive about public image and degrading the reputation of their organization, et cetera, and the coordination of the rest. So I think you have to ask, on average, what's the timescale between social revolutions of the scale that we're asking for here? And that's the timescale on which you should expect eventually people to, reveal stuff and admit stuff.
Yeah.
And that's not necessarily tied to the quality of the evidence.
Yeah, you may be right, because recently I had a podcast with Sean Ryan, and the one before that was with Cliff Sims, who served as the deputy director of national intelligence. And he mentioned that there was a discussion about unidentified anomalous phenomena with the director of national intelligence, and he was asked to leave the room. It was of the highest classification possible. And you may wonder why that is the case. Now, of course, it could be that they are worried that UAP are representing technologies that adversarial nations possess. But it could also be that it's something we don't fully understand and they're worried about it. In that case, scientists should be involved in the process of evaluating what it means. So I don't think we can brush aside and ignore the discussion within government, because these are serious people, and we can't just say it's nonsense the way academia reacts to it right now.
I completely agree. On the other hand, I just don't see any particular reason to believe stuff will happen soon.
Okay, well,
you and I are playing the long game. In the long run, we're trying to do stuff that will seem important.
No, I'm not playing. No, Robin, I'm not playing the long game. I will try to make it happen.
I will try with you, but still, if the primary obstacle here is sort of a social equilibrium of just looking down on something and not wanting to change your mind, then that'll take a while to change.
So here is my view on that. I say that sometimes it makes sense to rock the boat.
Sure.
Most people don't want to rock the boat, but when the boat is heading in the wrong direction, that's when you need to rock it.
But you should also choose your battles, as they'll say.
This is a battle I'm willing to die on.
And I've got a half dozen other battles, so I'm not sure this is my top one, but I'm happy to support it as I can.
Now, gentlemen, here it's worth noting, though, that there can be elements within a government, entrenched elements, that see a president as a temporary employee. In other words,
trustworthy.
He's going to be gone in 4 years, wait him out. And that's happened, So it's not that unexpected that a president isn't going to know everything or be given all information. But it does seem very strange how dodgy the U.S. government is on this subject, because if there's nothing there, there's nothing there. And it gets harder and harder to explain that by, well, they're trying to protect their sensors and capabilities and methods and all that in this. It's getting a little bit weird. Well, it has been for years.
I should say earlier this week, I had a special event at the Boston Museum of Science with a best-selling author named Patricia Cornwell. And she came with 2 bodyguards. She writes crime novels. And apparently she had a book that came out. And I was told at the event that she was inspired with the main character being me. So she was inspired by my work.
Right.
And the only unfortunate fact is that because it's a crime novel, that the astrophysicist who won the Nobel Prize, but I didn't, but at any event, is getting killed. And there is this theory that he was killed by aliens, dropped off a UAP. And then the detective figures out, based on the autopsy, a more terrestrial origin for the death. I said, I will not take it personally, but, it's really interesting to figure out what the government knows, because it may open a whole new mode of discussion, as Robin is referring to it, where the narrative will change as a result of that.
Now, one question that I had, listening intently, I'm like the student in the lecture hall professors, and I'm listening to the professors and enjoying myself. And my audience is the same way. I'm just the student that occasionally raises his hand. But and I want to hear complete answers, and it's been wonderful. But let me ask you this: a trigger for the intervention of an alien civilization that is present in the solar system could be some technology that is developed that may present a threat to them. Therefore, they mitigate the threat by having a presence and they watch us. Could this be artificial intelligence getting out of hand eventually? And that's when you see them, is when you get too close to artificial generalized intelligence that is indeed super intelligent. And perhaps that's the reason to be here. Like the zoo hypothesis, we were flirting with that. And that's the reason they intervene.
But they aren't actually intervening. They're hanging at the edge of visibility at best. So clearly, if they had a plan of, okay, they've gone too far, we need to step in and slap their face and tell them we're here and there's rules around here, then they would have done that. So if they're just going to wait till we pass some threshold and then drop the bomb on us, we'll never get a warning about that, right? So we can make our own guesses about how far might be too far that they would be scared of. Almost surely, if aliens are near here, they have a bomb of some sort and a button. And if we are past some threshold of danger, we'll just be gone. The question is just, do they give us a warning before that? And what possibly could be the threatening point at which we are so close to something that they would push the button? It would presumably be because at some point we would be beyond their button. But I think most plausibly we are just not remotely beyond their button at the moment. Like an alien civilization 100 million years more advanced than us, like what sort of a bomb could they have on us? It could be way bigger than we could handle now. And we are not remotely close to being able to protect against that or defuse it or anything like that. So if that's the threshold, we're pretty safe now, I'd say.
Well, just think about the fact that quantum mechanics was discovered a century ago. We still don't have a predictive theory that unifies it with curvature of space-time as an expression of gravity. We don't know what most of the matter in the universe is. We don't know what's inside a black hole. We don't know what happened before the Big Bang. Some very basic questions about the universe. And we are really in our baby steps in developing science and technology. So, yeah, we need to get much farther before we will get the respect we might hope to get.
All right, gentlemen, and I really enjoyed this. This mesmerized me. Wonderful discussion. And I hope someday maybe we can do it again as more information comes to light and the Galileo project perhaps learns more. I can't wait to see that data. And
I have to thank the senior partner here.
Oh, no, I don't at all. I'm just a farm boy, I haven't changed since I was 5 years old, and people that know me say that. So to me, seniority is completely irrelevant. In fact, I don't think of me as having any seniority in this. In fact, I really enjoyed, you are brilliant. And that's one of the most interesting conversations I had for a long while. So thank you, Robin.
Well, thank you.
This has been absolutely fascinating. But I do wonder because, the Fermi Paradox, where are they? Thank you, gentlemen. And I hope to do this again sometime.
Thank you all.
Thank you. It was a pleasure.
Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content. Sign up now by clicking the links below to your platform of choice.